Okay, so we're given that the probability density function p of x is defined as c times the ln of x on 1 to e, and we're asked to find the probability that x takes a value between 1 and 2. Okay, that's terrible, but yeah, 1 and 2. Okay, so what do we need to recall first? First of all, let's recall that for some interval j, some interval j, the probability over the integral over j of the probability density function is equal to 1. So what that's saying is, if x is defined over this domain, then it's certain, 1, that x takes some value on in that domain. So essentially, so let's say we have a function like this, so some probability density function, let's say. Okay, so some probability density function, the probability of some of x taking some value is given by the area under this curve. So if you want probability of x taking a value greater than some number, greater than this point, so we're looking for this area. Okay, if you want, so that's basically what you're looking for, and it says the area under this entire curve is going to be 1, because the probability of x taking a value is going to be 1 in that domain, right? Okay, so given that that's the case, so we know that in this case our j is going to be, j is 1 to e first, because we need to solve for what c is, right? And in this case we're going to get the integral from 1 to e of c ln of x is equals to 1. Okay, so we can just pop this c out because it's a constant. So c times the integral from 1 to e of ln of x equals 1, right? And now we need to get the integral of this, and it's just easy to remember. It's also, I mean, you could also solve this, but I'm just gonna tell you that this is equal to x ln of x minus x. Okay, and then we evaluate this between 1 and e. 1 and e, right? And then this is going to be c times e ln of e minus e minus 1 ln of 1 minus 1. Okay, so just evaluating both endpoints, so at e and at 1. So remember, just to recall, just to review what this is, right? We know that the integral between some interval a and b of some function f of x is capital big F, so the antiderivative at b minus the antiderivative at a. Okay, and that's the principle we're using here, and that gives us this result, which is going to be equal to c times 0 minus 1, and that equals to c. And we know that this whole thing has to equal 1, right? So therefore we know that c equals 1. So just to make it clear, so the integral over j of p of x dx equals c, which equals 1. Okay, so now we've solved for this, so now we can just let's just rewrite this. Okay, so this is going to be, so p of x equals 1 ln of x. So just ln of x, right? Okay. Now what we actually have, what we want to find is this value. So now we take this and we integrate over this interval. So the integral from 1 to 2 of ln of x, okay, dx, which is x ln of x minus x evaluated between 2 and 1, which is 2 ln of 2 minus 2 minus ln of 1 minus 1, which equals 2 ln of 2 minus 2 plus 1, which is 2 ln 2 minus 1, which is approximately 0.38. Okay, so that's the answer. So this is the probability that x takes a value between 1 and 2. So just write that out. So probability that x is less than or equal to 2 and greater than or equals to 1 is this. Okay.